Hello world, my name is Victor Engelmann, and in this video I'm going to show you how to debug your programs with the GNU Debugger GDB. Now, what's debugging? Well, if you are a programmer, chances are that you started programming with an integrated development environment, an IDE. And typically IDEs like Qt Creator or Visual Studio or whatever, they come with an integrated debugger, so you start your program and if it crashes, it gives you all sorts of information about the crash. And it allows you to pause your program and change things and so on. So, but you might not always have an IDE, you know, in IoT scenarios, for example. Let's look at GDB, which is a debugger that works on a text shell. I've prepared just a simple program here, and let's just jump right into it. And I want to show you a little bit of how to do the typical things, because chances are you are here because you want a quick answer to how to debug. So I want to quickly answer that and then later dig deeper into the topic, okay? Now, this is just some random program that doesn't do anything spectacular. It reads a number, W, and then I'll just show you what it does. So it reads a number like 6, and then it starts counting 0, 0, 1, 0, 1, 2, 0, 1, 2, 3. And since we end with less than, that's why we don't get to 6 here. Anyhow, that's nothing spectacular, okay? It's just some example program, okay? And this is my makefile. It really just compiles the program and run starts it then. Okay. Now, if you want to debug with GDB, then your program, GDB needs debugging symbols. And one simple way to get debugging symbols is just to put -G here. So when you compile your program, -G tells the compiler to put debugging symbols into the final file. So then you have debugging symbols, okay? And it might also be a good idea to turn off optimization with capital O0, because optimization can change things around in your program, and then it might not be so clear what happens where. So people would typically advise you to turn off optimization for debugging. Okay, so I'll delete the program and make it again. Okay. Now, again, I can input a number, and then it prints this this list of numbers. Really nothing spectacular, okay? Now, since we have debugging symbols now, we can start GDB and give it this GDB test, okay? And you can already see here it tells us it's reading the debugging symbols from GDB test. Okay, and now, in here we now have a shell, a GDB shell, through which we can control GDB. And let's, for example, say we might want to put a breakpoint in line 10, okay? So every time we are done printing one line, it should break, okay? So I would just say break for setting a breakpoint. And now I need to specify a location, and the location could be GDB test.cpp : and I wanted line 10, right? Okay, now I have breakpoint 1, and if you're interested, I can also delete that breakpoint again. So if I now say info breakpoints, you see there are no breakpoints left, but I'll set the breakpoint again, and now if I say info breakpoints, there's my breakpoint again. Okay, now so far the program hasn't even started. You know, we've just loaded the program and configured our GDB session. Now with the command run, I can now start the program. Okay, now it's waiting for my input. Let's say 8. Okay, now it has hit the breakpoint. Well, in the first iteration, it just doesn't print anything. The first line is with I equals 0, and yeah, that immediately terminates. So the first line is empty, and then I hit this cout standard end line, and yeah, this is where my breakpoint is. So now I have hit this breakpoint, and now I can say continue. So it when I say continue, it runs again, and until it hits the next breakpoint. It's a bit strange. It doesn't seem like it has printed something yet, but I think that's probably something due to buffering. You know, the output of the 0 is probably just buffered, and the buffer isn't flushed. So maybe output something. Yeah, whatever. So let's say, so you've seen I can continue, which means when I've hit the breakpoint, I've stopped. Okay, and if I say continue, I tell it to start running again until it hits the next breakpoint. Okay, so at this point it returns here, and then I is increased, and A is called again with the next I. So then this this loop is executed again. We are writing the next line, and then we hit the breakpoint again. Now, something that GDB can do that I haven't seen in other debuggers is you can say continue, but give it a number of iterations. So yeah, let's say 4. So now it will ignore this breakpoint 2 for the next 4 iterations. Okay, so now now I get my my output, and I wasn't interrupted for the next 4 lines. Okay, so I think that's pretty useful, because I know that I have often been in the situation where I've been debugging with a graphical debugger, and it was quite hard to say, okay, continue, 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 and yeah, with continue plus a number, you can tell it to continue for a number of times. I think that's really useful. Another thing that you might want to do when you're debugging something is you might want to look at a stack trace. In GDB, that's called a backtrace. So if I tell it backtrace, it gives me this, what I would call a stack trace, and you can also use BT as a shorthand, and then it tells you main has called B and B has called A, right? So main has called B and B has called A. So that's your stack trace. And yeah, maybe you want to look a bit deeper in the into your stack. So now I can go to stack frame 1, which is the call of B. Okay. Now I'm looking at this execution of B, and I'm probably interested in the value that some variables have. So you can say print which variables do we have in this stack context. Well, we have W and we have I. So let's print I. It tells us I equals 5. So now we know, okay, the value of I at this point is 5. Okay, and that makes sense because we've already seen the line for I equals 4. So it makes sense that we are now in the case where I equals 5 up here. Okay, now let's say you are debugging your program and you found some error, okay? And maybe I've determined that this value for I wasn't legal. So yeah, maybe I don't want to immediately change my program, recompile and restart. Maybe I want to see if what happens if this wrong assignment of I hadn't happened in the first place. What you can do now is you can set var I equals, I don't know, let's say 5 was wrong and I want it to be 2 now, so I can change it to 2. If I print it now again, I have the value 2, and so what you've seen now is this here is the output for the case where I was equal to 5, right? This was buffered again. And after we continued, this buffer has been flushed. So now we see this output. And because we've changed I to 2, yeah, we've basically went back in time in a way. And now we are going through the case of I equals 3 again, you know, because we set it to 2. And when this returned, then it was increased again to 3, and then the next iteration was the line for 3, which is 0, 1, 2. Okay, I think that makes sense. And now the program has ended, and yeah, we can exit GDB with the command quit. GDB is really a very powerful tool, and it has a lot of options and gives you a lot of ways to deal with programs and for analyzing programs. I can absolutely advise you to go to the GNU homepage, gnu.org/software/GDB. That's the homepage of the GNU Debugger. And here you have this link to documentation. And then here you have GDB user manual. And this is really a very useful resource for GDB. Ignore the stuff up here. Look here in the table of contents. This is really well structured. You have really good topics for the different sections, for the different chapters. Here, continuing and stepping is a very good resource that shows you step is what you possibly know from IDEs, the step into a function. You know, when your debugger is at the line of a function call, then a step will step into that function. Next is what you might know as step over. So if you are on a function call, next means go to the next line. So don't go into the function, just go to the next line. Okay. there's many more things, like finish means continue until you hit the end of the function, until yeah, some graphical debuggers give you an option to say to specify a line and then say continue running until you hit this line. I mean, that's basically nothing different than saying, then putting a breakpoint on that line and then saying continue, but yeah, that's still there. Advance is basically the same thing. Yeah, the only difference is that until will also break when you exit the function. So that's like, so until is like finish or advance. Okay. And yeah, finish is what you might know from graphical debuggers as step out of the function. Yeah, there's a lot of things that you can do, and as I said, this official manual is really good, and as I said, it's really well structured. I really like it. I can really advise you to bookmark this, and when you have any questions about GDB, look here for answers first, because it's really good. So let's do some more stuff with GDB. Let's say you've started your program normally without a debugger, and you're using it, and you notice that it is misbehaving in some way. Yeah, since you haven't started it from the debugger, what can you do now? Well, you can take GDB and attach it to an already running program. And yeah, for that you need the running program's process ID. And with ps-a you can get that. So here's your GDB test. So this is my process that I'm looking at. This is a process ID. And yeah, attaching to an already running process might require administrator rights. So I'm going to sudo GDB. Okay. And now I can just say attach, give it the process ID, and yeah, now I'm attached to the running program, and I think this already pauses the running program. So so I could now say continue to unpause it, but yeah, let's I mean, the purpose of pausing it at this point is so that you can start doing stuff like setting breakpoints or so. So let's see, GDB test line 10 again, okay? Break GDB test CPP line 10. Can we look at a backtrace? Yes, we can already look at a backtrace here. So it's waiting for a read, as you can see here, which is defined in libc. Okay. And now we can say continue, it's continuing. And right now nothing is happening, so it doesn't prompt us to do anything. I'll input 6 here, and yeah, now we have hit the breakpoint. And yeah, we can again look at backtraces or print variable contents or change variable contents, whatever. I don't know, let's go to frame 1, set the variable I to 4 and continue 100. And yeah, now after we've changed I to 4, it went into the next iteration of 5, which printed this line. Then it went to 6, and as 6 was our upper limit, that's where it stopped. So yeah, you can see we've successfully analyzed the program we've written to its variables, and yeah, so this is how you can debug already running programs. Now at this point it has exited, so we cannot detach it from it again, but yeah, with the command detach, you can detach from a running program. That's the opposite of attaching, obviously. Now, doing all this in a shell can be tedious if you are debugging something larger. So, of course, there are other tools out there, and for example, there's KDBG. You gotta be careful here because there's also KGDB, but that's a project that deals with debugging the Linux kernel. But KDBG is a graphical tool for KDE for debugging. Okay, and here you can load a program, GDB test, for example. And this is basically a GUI front end for GDB. So here you see your source code. With F9 you can set breakpoints. You know, this is just more convenient than going back and forth between your text editor and looking for line numbers and then remembering the line number and typing them into the GDB console. It's just more convenient to have your source code here and then just press F9 and you have a breakpoint here. Okay, so let's remove the breakpoints, and then you can say execute. Now it starts the program in this little window, and yeah, I'll input 7, and now you see this little green arrow here that tells you, hey, I have hit the breakpoint, here's your stack trace, and over here you can see the local variables of the stack frame that you've selected here, so you don't need to type in, hey, I want to go to this stack frame, I want to go to this stack frame. You just click it and then you see all the local variables over here, and that's really convenient. And you have typical keyboard shortcuts for, well, with F5 you continue. Okay, so if you look over here, this W, if I hit F5, 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 it's always the next encounter of this breakpoint, right? So when I hit F5, it continues running, leaves A, goes into A for the next iteration, hits the breakpoint again. Okay, and over here you see the output, and the output isn't so so mixed together with the output of GDB. You know, that's also more convenient if you ask me. And yeah, then you have these typical functions for debuggers. As I said, F5 is for continuing. F10 is the next, so a step over. F8 is step, so stepping into a function. F6 is finish, so stepping out of the function. Yeah, let's just do some of these. So with F6 I can now jump out of the function, so it's now finished this and is now in this for loop, and yeah, let's say F10 is now going into A again with F8 I can jump into the function F10, 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 F10. So now I'm looking at the loop being iterated. F10, F10, so now I have exited the function. F10, now I'm going with F8 into the function again, iterating it with F10. One more time, F10, oops, okay. Now it's finished. Okay, so this is KDBG, not to be confused with KGDB, but yeah, as I said, this is another useful thing. You can set expressions that you are watching, and then while you're debugging you can see how values change over time. And you can also do that in a GDB session. Well, first you need to get into a context where such an expression is valid. So let's put a breakpoint on line 16. And run. Input 8. Okay, now we've hit this breakpoint, and now I can tell it to watch the expression I, and continue. And now it tells me, hey, since the last breakpoint, this watch point I has changed from 0 to 1. Okay. Continue again. Okay, it seems to hit the breakpoint twice, probably once when it enters the function and once when it exits. I don't know. Okay, you see, I always have to continue twice, so until this has changed from 1 to 2 and here from 2 to 3. Okay, one more thing I want to mention is that with an exclamation point you can run just some shell commands and for example clear. That can also be useful, and if your program expects some arguments, you can set, before you run your program, you can say set args, I don't know, foo-bar butts. So then foo-bar butts will be the arguments that will be passed to your program. You can think of GDB as an environment around your program that sets up the environment of your program. So it kind of makes sense to have the arguments inside of your GDB session here. But you might want to pass them directly through the command line, and you can do that with --args. But something that I find a bit stupid here is you need to repeat the program name here as the first argument, because yeah, otherwise it would then try to run a program called foo, and that doesn't exist. So, or in the worst scenario, it does exist and you're running something completely wrong. So yeah, just do this as args, run, and now it's running GDB test. Okay. Yeah, there's a lot of more things to know, like I don't know, you can get a listing of your program, you can set environment variables, you can unset environment variables. Yeah, there's just a lot of things that you can do. I would really advise you to look into the manual if you have any more questions, but I think this has been quite a good overview over the topic, and but I will make another video about some more advanced stuff, like remote debugging and debugging with separate debugging symbol files and stuff like that. But yeah, for this video, I think this was enough for today. So if you liked this video, like it, share it, subscribe, and see you next time.